Hello everyone. I am a quality control engineer at Plutools. Today, I will provide a detailed introduction to the 4 core quality control processes prior to the X-factory release of the drive wheel, the intermediate inspection standards, and the accompanying debugging specifications. Our patrol inspection work is primarily divided into the following 4 key stages. 1. Material verification. Core task during the assembly process. Quality inspectors must strictly cross-reference the traveler with the engineering drawings. Key points. Confirm that the brake voltage, for example, 24 volts or 48 volts proximity switches, home switches, and status indicators match the order requirements. Standard operating procedure. If the production pace is tight, each drive wheel must be verified individually to ensure zero material discrepancies. 2. Motor testing. Drive motor test. Low speed test at 200 revolutions per minute. Perform a radial run-out test. The standard allows for a swing amplitude within 5 minor grid divisions. Current standard is strict lie within 2 divisions. No load test. Release the brake and conduct a high-speed no load test. The motor no load speed current lie reaches the rated 3000 revolutions per minute. Noise and current. Inspect using a calibrated sound level meter. The standard requires noise to be less than 70 dB at a distance of 1 meter, with a stable current of approximately 3 amps, and absolutely no abnormal sounds. Special scenarios. For TC250 large diameter or vertical drive wheels, a lifting test will be conducted in an open area of the workshop using an overhead crane. Steering motor test. Conduct high-low speed and forward-reverse full rotation tests. Use a multimeter to check the long arm or normally open states to confirm normal signal transmission. 3. Auxiliary performance inspection. Home switch verification. Based on traveler information, for example, AP6X PMP or NP6X, perform a power-on test, 24 volts using a multimeter. Operation. When the sliding line indices the home position, the indicator light should illuminate. Upon moving away, the light should turn off, and voltage should return to 0. This confirms the proximity switch and wiring are correct. Limit switch test. Connect the white and black wires and rotate to the limit switch trigger point to confirm the device stops or responds normally. Cable position angle calibration. Mark a line directly above the home switch. For example, a 120 degree cable position angle refers to the angle between the limit switch center line, the drive wheel center line, and the striker block center line. It is essential to accurately distinguish key angles such as 90, 120, and 160 degrees. Fastener spot check. Use a hex key to spot check the slewing bearing bolts to confirm they are tightened and marked. 4. Appearance and overall inspection. Appearance check. Confirm there is no external damage. The unit must be returned to the 0 position before leaving the factory and have a clear center mark. Hard limit position setup. We recommend customers rotate at low speeds. In the event of high-speed loss of control, the hard limit position acts as a safety mechanism to prevent impact damage or breakage, providing extra protection for the customer. Drawing review. Verify appearance details such as the steering, motor position switch sequence, and motor installation direction. For example, if the drawing specifies the left side, it must not be installed on the right. Part 2. Intermediate inspection and key parameters. Upon completion of all the above inspections, the intermediate inspector will conduct a final review, focusing on the following 7 key points. Motor voltage, multi-wheel braking, nameplate information, signal angle, motor installation direction, appearance status, slewing bearing and gear backlash. Top priority. Rotate to one side and clamp the middle tooth. The backlash must be controlled to within 0.4 m. Inspection tool. Use a feeler gauge If 0.3 mm cannot be inserted, but 0.25 mm fits with slight resistance, it is considered qualified. Part 3. Documentation and Debugging Delivery. 1. Inspection and Debugging Forms. Patrol Inspection Record records all parameters, including encoder verification and total extension cable length. Intermediate Inspection Record records the final inspection results. Debugging Form, for example, for Kinko motors, provides a corresponding debugging form containing the factory UV wiring, configuration, and debugging parameters. Purpose: to ensure no load operation is free of noise and vibration, facilitating quick customer setup by simply inputting parameters, and also aiding efficient after-sales support. 2. Data archiving. All inspection records and debugging forms will be archived and uploaded to the company's shared drive. Traceability supports queries for up to 3 years. Customers can retrieve wiring configurations and no-load debugging records from that time at any time.